Question says the perimeter of a rectangle is 20 centimeter. Find the minimum value of product without any unit of the length in centimeters of the two diagonals. Correct. So there is this rectangle. There is this rectangle, and this is the these are the diagonals of this rectangle. Correct. And the perimeter of rectangle, I know this is length, this is breadth. Perimeter I know is 2 times length plus breadth, and it is given as 20. So I can say this sum length plus breadth is 10 only. Correct. The sum of length and breadth is 10. So I can have so many values for length and breadth, right? It is just that the sum of these two lengths must be equal to 10. Right. Now we have to find the minimum value of product without any unit of the lengths of the two diagonals. Okay, so I know in a rectangle, length of two diagonals are equal. Length of two diagonals are equal. Also, in this case, I'm assuming the length of one diagonal is d. So I know d square is equal to, because I'm taking this triangle. Let's just take A, B, C, D. So let's just take this triangle ABC. In this triangle, d square would be equal to AB square plus BC square, correct? And which is equal to length square plus breadth square. If also this d square would be the product of the lengths of two diagonals, and I have to minimize this value. Right? Minimum value of d square. Now I have this length plus breadth is equal to 10, right? If the sum of two numbers, right, and these are positive real numbers, sum of two numbers is 10, I can say that their arithmetic mean is greater than equal to their geometric mean, correct? So AM of these two numbers would be 5. It has to be greater than or equal to product or square root of the product of these two numbers, that is length into breadth, correct? So this length into breadth, this product has to be less than or equal to 25. Okay, so why are we calculating this thing? We'll know in a moment. So we have to minimize the value of this expression L square plus B square, right? And this expression comes from squaring this. I know L plus B whole square is L square plus B square plus 2 times LB, correct? And L plus B whole square is given as what? 100. 10 square is 100. 100 is equal to L square plus B square plus 2 times length into breadth. Then from here, L square plus B square would be 100 minus 2 times of LB, correct? So this boils down to 100 minus 2 times of LB. And we have to minimize this expression. If we have to minimize this expression, I need this term as maximum as possible, right? Because I'm subtracting something from this constant 100. So I need this term to be as maximum as possible, correct? And the maximum value of this product LB can be 25 only, because the product has to be less than or equal to 25. So the minimum value or the minimum value of the product of lengths of two diagonals would be 100 minus, when I use the maximum value of LB, and that is 25. So I get d square minimum as how much? 50, because 100 minus 50 is 50. So correct answer to this question is 50.